So we've got use comparison method to solve systems of linear equations for our last 8th grade spring math topic. Some key ideas here. What we actually call this is solving by substitution. And we'll talk about how we substitute things. There's going to be inverse operations involved. And when we're solving for variables, we're going to have variables on both sides of an equation. I like to think of the concept where I'm separating the variables from the constants. So put variables on one side of the equation, constants on the other side of the equation, and then negative signs constantly get in the way. So I try to keep things as positive as possible. Math tip and life tip. So we're going to start off with the reason that we can use substitution is because y is by itself. So anytime we have a variable by itself, we are allowed to substitute what it's equal to anywhere we see that variable. And in this case, that y is by itself in the other equation as well. So the reason for doing this is to create an equation that only has one variable. So these equations have two variables. We have an x and a y, x and a y. Now we've got an equation with just one variable x, which we know how to solve for. And this is when I look at these right here. We're going to use inverse operations, and I'm going to try to separate the constants and the variables. So right now I have a variable and a constant. Constant is just a number that doesn't change. So I have a constant and a variable. I'm going to move this one because that's going to keep my variables positive, which I mentioned, always better to have positives as opposed to negatives. So 5x plus 2x gives me 7x. So now that I've established that I'm going to put the variables on the right-hand side, I want to put the constants on the left-hand side. Let me change colors here. So that means I want to move this 8 over here. And as you can see, I have constants on the left-hand side and I have variables on the right-hand side. Furthering, trying to get constants and variables separated. All right, I still got a number over here, which isn't a constant, it's a coefficient. However, I want x by itself. That's the goal of algebra when you're solving for a variable, to get the variable by itself. So because it's x times 7, the inverse operation is dividing by 7. 0 divided by 7 is 0. So we find out that x equals 0. However, in this system of equations, we have two variables we have to solve for. We just figured out x. Now we are going to go after y. So we're going to use substitution again. Since we found out that x equals 0, we can substitute 0 in anywhere we find x. And it doesn't matter which equation. If I use this bottom equation and I put 0 in for x, 5 times 0 is 0. 0 minus 8 is negative 8. So y would be negative 8. If I chose to use this equation, y equals negative 2 times 0 minus 8. Negative 2 times 0 is 0. 0 minus 8 gives us the same idea. So it doesn't matter which equation you use in order to figure out what your y is. They're both going to give you the same result. Let's look at another one. Same concept. Since we have y equals an expression, we can substitute that expression in anywhere we see y, which we see in the other equation. So we got negative 3x minus 1 equals 6x minus 19. And now we get to the part where we're going to put variables on both sides. Or variables on one side. So I'm going to move this, since it's negative 3x, the inverse of that, in order to undo it, is to add 3x. So I'm going to get 9x on the right-hand side. And as we mentioned, we want to put constants on the other side. So I'm going to add 19 because adding is the inverse operation of subtraction. So negative 1 plus 19 gives me 18. And then when I try to solve for x here, the inverse operation of multiplying is division. So 18 divided by 9 is 2. That's what our x is. We got x by itself. And next step, we got to figure out what y is. So because x equals 2, I'm going to substitute that 2 in for x. So y equals 6 times 2 minus 19. Y equals 12 minus 19. And 12 minus 19 is negative 7. So y equals negative 7. I realized that I was putting the variables on the right-hand side each time. That's not a necessity. Once again, I was just trying to do that to avoid negatives, but let me do this last one. Same idea. I'm going to substitute negative 6x plus 2 in for y in the other equation. Well, let me go ahead and put the variables on the left-hand side just to show you that it can be done. So to undo negative 4x, I'm going to add 4x to both sides. And this goes against my own personal preferences, but it doesn't mean it's not okay. Negative 6x plus 4x is negative 2x. So I end up with a negative, not a big deal. Mathematically, it's still correct. But since I put the variables on the left-hand side, now I'm going to put the constants on the right-hand side. So the inverse of adding 2 is subtracting 2. So I get negative 6 over there. So to continue getting that variable by itself, since it's x times negative 2, the inverse of multiplying is dividing. And x, when I take negative 6 divided by negative 2, I get a positive 3. So x is positive 3. But as we've seen before, we have to figure out what the y is. We can go to either equation. So I'm just going to go to this top equation, substitute 3 in for x. So y equals negative 6 times 3 plus 2. And just order of operations, negative 6 times 3 is negative 18. And negative 18 plus 2 is negative 16. So y equals negative 16 when the x was 3.